Now in this video I want to talk about the uses and application of C5 to C8. So the next four alkanes are free-flowing volatile liquids. Isomers of pentane, hexane, heptane, and octane are the primary constituents of gasoline. Their volatility is crucial for this use because the injection system simply squirts a stream of gasoline into the intake air as it rushes through. If gasoline didn't evaporate easily, it would reach the cylinder in the form of droplets, and droplets cannot burn as efficiently as the vapor, so the engine would smoke and give low mileage. In addition to being volatile, gasoline must resist the potentially damaging explosive combustion known as knocking. The anti-knock properties of gasoline are rated by an octane number that is assigned by comparing the gasoline to a mixture of N-heptane, which knocks badly, and isooctane, which is 2,2,4-trimethylpentane, which is not prone to knocking. The gasoline being tested is used in a test engine with variable compression ratio. Higher compression ratios induce knocking, so the compression ratio is increased until knocking begins. Tables are available that show the percentage of isooctane in an isooctane heptane blend that begins to knock at any given compression ratio. The octane number assigned to the gasoline is simply the percentage of isooctane in an octane heptane mixture that begins to knock at the same compression ratio. And here I will show you the two different compounds we have. On the left hand side we have normal heptane, which has 0 octane, and it is very bad for knocking. And on the right hand side we have isooctane, which resists knocking, and we call it 2,2,4-trimethylpentane, and the octane is 100 octane, and the normal heptane is 0 octane. So basically for all gasolines they are changing from 0 to 100 based on what we have in their composition of the gasoline.